Bismillahirrahmanirrahim. Welcome to Pakistan International School Taib, grade 12, second year, lecture number 23. And we are talking about chapter number 14, D block elements. And the topic today is iron. This is a very important transition element and we use in our daily life. So what the three topics, subtopics we are going to discuss about the iron. Page number 82. See the page number 82, and we will discuss iron number 1. Number 1 is oxidation state. Number 2 is iron as a catalyst. Iron acts as a catalyst, oxidation state, and this is going to be used for the preparation of ammonia, Haber's process. Haber's process for the preparation of ammonia, iron acts as a catalyst. Number 3. Iron exists in two common oxidation states, iron 2 and iron 3. Iron 2 and iron 3 oxidation state generally called ferrous and ferric. So it will be formed with a complex. We done the complexes. Iron can form complexes with water, with ammonia, carbonate, and thiocyanide. Thiocyanide ion, SCN. Thiocyanide ions. So iron can form complex with water, ammonia, carbonate and thiocyanide ions. These are the ions. Yes. Now number 1, oxidation state, 1 by 1. Iron exists in the two common oxidation state. Already I told you, positive 2 and positive 3 oxidation state. So it is going to oxidizes iron positive 2 ions to be in the aqueous solution, changes into iron 3 by the loss of 1 electron. So this is oxidation process. The iron is thus reducing agent because it is going to be oxidized itself. So the substance which oxidizes itself is called a reducing agent. In solution can be determined by the titration. So in the titration you done ferrous sulfate changes into ferric, there was oxidation, and potassium permanganate was as a oxidizing agent. So iron sulfate is a reducing agent. So number 2 now. In number 2, the catalyst in Haber's process. So ammonia is going to be prepared nitrogen gas plus 3 moles of hydrogen gas equilibrium to form ammonia gas. This is the Haber's. This is the Haber's process for the preparation of ammonia. You students done in the grade 11 and also grade 9 equilibrium chapter. So 1 mole of nitrogen and 3 moles of hydrogen to give a 2 moles of ammonia. This is the equilibrium mixture. The equilibrium mixture is going to be formed in equilibrium mixture. So this process is not profitable. So when you are going to apply conditions according to Richet-Pierre's principle, so iron acts as a catalyst. This is iron. Iron acts as a catalyst, and 450 degrees Celsius and 200 atmospheric pressure. So 200 atmospheric pressure is going to be applied. So this is the Haber's process where catalyst is going to use. The catalyst substance which accelerate the chemical reaction, increase the speed of the chemical reaction. The nitrogen reacts with 3 moles of hydrogen to form ammonia gas. Now there is another one. Iron acts as a catalyst in the reaction between persulfate ions and iodide ions. Catalyst. We are talking about iron acts as a catalyst. So, persulfate ion. Persulfate is S2O8 negative and iodide ions. Persulfate ions and iodide ions, iron acts as a catalyst. The reaction between the persulfate ions and iodide ions in solution can be catalyzed by using iron positive 2 or iron positive 3. So you can see here, this is the formula I told you, S2O8 negative 2 whole and 2 iodide negative 1. Iron acts as a catalyst to form sulfate SO4 in aqueous negative 2 and a free iodine solid. This is also in aqueous solution, this is also in aqueous solution. Now in the persulfate, oxygen is negative 2 and total negative 2. Negative 2 multiplied by 8, negative 16. So it means that there should be a positive 7. Positive 7 multiplied by 2, positive 14 and positive 16, you will get negative 2. And here sulfate is a positive 6. And iodine is negative 1 and changes into 0. So dear students, positive 7, positive 6, this is a reduction. And this acts as oxidizing agent. And this is oxidation. And acts as reducing agent. So positive 7 to positive 6. Decreased oxidation number is called reduction and acts as an oxidizing agent. Iodide negative 1 to 0, increase in oxidation number is oxidation and it acts as a reducing agent. So for the sake of argument, we shall take catalyst to be iron positive 2. So how it acts as a catalyst? So S2O7 negative 2, and this is the iron acts as a catalyst, and this is going to be sulfate negative 2 aqueous and this iron is going to be positive 3. So in the case of iodide, this iron positive 3 and 2 iodide ions in the aqueous solution, and you will get again 2 iron plus iodine. So this is how the catalyst see in this reaction. Iron 2 changes its oxidation state to give a positive 3 there oxidation, and positive 7 oxidation number of sulfur changes into positive 6. There is a reduction and iron is going to be oxidized for the time being. Catalyst will recover same. So in iodide also this iron positive 3, because iodide changes into iodine, this is oxidation, and iron which in use has a positive 3 and it changes again into positive 2. So the same iron positive 2 is recovered during the chemical reaction. So if we use iron 3, the second these reactions happen first. This is a good example of use of transition matters compound as a catalyst, because they have ability to change their oxidation states. Already we done introduction of transition matters. They have the variable oxidation state due to the unpaired electrons, as well as these transition matters have ability apart from the d electrons, they participate also s electrons. That's why they have the more than one oxidation state, and it's a very good ability for them to use as a catalyst. Temporarily they change oxidation state in the last, same is going to be recovered. So this is the use of catalyst in the persulfate and iodide ions. So students, write down this very well, these chemical reactions. Right, please. The second topic is reaction of iron ion in solution. Reaction of iron ion in solution. This iron ion will be positive 2 and will be positive 3. Both are the iron ions. Now we did the complexes. In the previous lectures and topics, we done the complexes. The complexes iron, water, students, you done the nomenclature of the complexes. Water is a neutral ligand. Overall complex have a positive 2, means this is a cation. Hexa, aqua, because there is no positive here potential like this one. Hexa, aqua, iron 2. Hexa, aqua, iron 2 neutral ligand. This is the one complex. A second complex is and this is the hexa, aqua, iron 3. Hexa, aqua, iron 3. Oxidation number of iron is 3. The reaction of iron ions with hydroxide ions. We will see down here the chemical reactions are given. Open page number 83. This is the page number 83. Hydroxide ions, suppose we have sodium hydroxide. Suppose we are saying hydroxide ions from the alkali, caustic soda, sodium hydroxide, hydrogen ions from the water ligand attached to the iron ions. So when enough hydrogen ions have been removed, you are left in the complex with a low charge, means neutral complex, low charge, neutral complex. And this is insoluble in aqueous solution and you will get precipitate. Neutral complex will be precipitate. You will get a neutral one. So this we are talking about this one. So this is the hexa aqua iron 2 plus hydroxide ion, we say sodium hydroxide, 2 ions of sodium hydroxide, and you will get a neutral complex. And what's a neutral complex? Iron, water, 6 changes into 4, hydroxide, 2, and this is the neutral complex will give precipitate and 2 moles of water. Now according to the rules of nomenclature, the name of this is called tetra aqua. Tetra alphabetically tetra aqua dihydroxo iron. This is the neutral ligand. Hydroxyl group has a negative 1, multiple negative 2, so positive 2. This is a whole neutral. So the oxidation state of iron is 2. So name of this complex is, which is a neutral, which gives the precipitate tetra aqua dihydroxo iron 2. And this precipitate is green. See in your book. Hexa aqua iron 2 is a pale green, which is a pale green, very light green you are seeing. Then you are adding sodium hydroxide according to page number 83. So it changes into tetra aqua dihydroxo iron neutral complex, and you will get a gelatinous green precipitate. So he said on standing, on means wait for a few minutes. On standing it give a dark green, and up top you will get the pink small crystals. Small crystals are going to be formed. So it means that in the last you will get a small red crystals and green precipitate on standing, which is going to be dark green. You can see this dark green. Now same as this, if you have a positive 3, this is a positive 3, and there are 3 hydroxyl ions in aqueous solution. So in the next chemical reaction, you will get tri-aqua, tri-hydroxo, tri-aqua, and tri-hydroxo, and oxidation number of iron will be 3. So this complex is called tri-aqua trihydroxo iron 3, and this again neutral complex and has a low charge and give the precipitate. And this precipitate is orange. If you see your book, orange precipitate is going to be formed. And actual color of hexa aqua iron 3 is hexa aqua iron 3 is a yellow. Yellow color of the hexa aqua iron changes upon addition of sodium hydroxide. See page number 83. You are getting orange precipitate. So these are the color changing of iron 2 and iron 3 complex with sodium hydroxide. Page number 84. See page number 84. Iron is very easily oxidized under alkaline conditions. Yes, we done this. Oxygen in air oxidizes the iron 2 hydroxide precipitate to iron 3 hydroxide, especially around the top of the tube. Already I told you, small pink top reddish is visible. You can see the darkening of the precipitate comes from the same effect in the iron 3 case also. Now, number B, reaction of iron ions with ammonia solution. Reaction of iron 2, 3 with ammonia solution. Reaction of iron 2, 3 with ammonia solution. So students, if you see the chemical reactions you are seeing here, now this is a very important. This is a very important. Ammonia acts as, in some chemical reaction, ligand or ligand and base. So we will see the reaction of iron complex with ammonia. So how the ammonia will act as a base and acts as a ligand. So you can see the chemical reaction. The reaction is hexa aqua iron 3 iron hexa aqua iron 3 aqueous plus 2 moles of ammonia. So what you will get the same, no difference, the product as you done with the hydroxide. No difference. Iron and hex tetra aqua and dihydroxo iron 2. This is the iron 2 first, then I will write iron 3. So this is the neutral complex with the ammonia changes into ammonium. So in this case, hexa aqua iron 2 is a very light green color. See the book? So it changes into tetra aqua dihydroxo iron neutral complex. This is a granulaceous green. In the last standing, I told you that is a dark green precipitate. On the top On the top you will see the red, some particles, red particles like this one. You can find on the top red particles. The appearance is just the same as we done for the previous reactions. You add the sodium hydroxide. The precipitate again changes color as iron 2 hydroxide complex, same 100%, no difference, is oxidized by air and iron 3 hydroxide. So students, I have written ammonia acts as a ligand and base. Ligand means the iron should be present in the square bracket. Just like water is a ligand and hydroxide is also ligand. So, but here ammonia is not not written in the complex. So in this reaction, ammonia acts as a base, not ligand. So this reaction is for the iron 2 and same reaction in iron 3. 100% same. This is the iron 3. The color is a yellow color if you see your book. Yellowish orange color, and ammonia 3. 3 moles of ammonia will be formed, and the reaction you will get of 3 like this. Aqua trihydroxo iron 3, the 3 ammonium ions, and this color is a orange, reddish orange precipitate. Reddish iron precipitate is going to be formed here. If you see the page number 84 in the test tube, yellowish hexa aqua iron 3. So you are going to add ammonia as a base, and it changes into aqua trihydroxo iron 3, and the color is, I told you, orange color is given there. Now a reaction with carbonate. With the carbonate. You can see the reaction here with the carbonate. Iron 2 aqueous plus carbonate aqueous, and you will get simple iron carbonate. This is solid. So the hexa aqua iron 2, hexa aqua iron 2 plus carbonate is iron 2, and changes into this, the green again I told you, very light gelatinous green, and you will get the dark green of iron carbonate solid. Iron carbonate solid is going to be formed here. So students, these are the chemical reaction and ammonia acts a base in these reactions with the iron 2 and iron 3. Now the next reactions are reactions of iron 2 and iron 3 ions with the carbonate ions and thiocyanide ions. Reaction of iron 2 and iron 3 ions with carbonate ions of thiocyanide. is the thiocyanide. So iron 3 ions and carbonate ions. You can see the chemical reaction here. Iron 3. So this is the iron and hexa aqua, iron 3, 2 moles aqueous ions plus carbonate -2. So we will get the complex iron and 3 tri aqua and same result, trihydroxo, orange. We get the same one, plus 3 moles of carbon dioxide gas and 3 moles of same we done this. So orange precipitate is going to be formed here. Depending upon the proportions of the carbonate ions to hexa aqua ions, we will get either hydrogen carbonate, means HCO3, hydrogen carbonate ions form on the carbon dioxide gas. For the reaction between hydrogen ions and carbonate ions, the more usually quoted equation shows that formation of carbon dioxide gas. The reaction is given here. Now other one is a testing for the iron 3 ion to iron thiocyanide. You can see the chemical reaction. Hexa aqua iron 3 reacts with thiocyanide. This is thiocyanide. You will get the thiocyano penta aqua thiocyano iron 2. Penta aqua thiocyano iron 2. So this is the blood red color. You will get from yellow to blood red color here. So students, here we stop, and in the next lecture number 24, so we will study about copper. Thank you.